Hi, in today's video I'm going to be showing you how I go about replacing a crystal in the system. For demonstration, I'm going to be using the second OPA crystal. The first step that I use is to scan the system until that crystal is at normal incidence, where its position should be reading 0. To determine normal incidence when I'm building these systems, I use a Heaney that I bring in through the exit port. In the field, I would simply use the green light that's available in the system. From the Heaney that I'm bringing in right now through the hole in this card, I'll see 4 spots from each of the 4 crystals. 2 to the left of the hole and 2 to the right. The 2 to the left are lower and the 2 to the right are higher. That's due to the fact that the mounting block hole is drilled 1 degree away from normal to avoid back reflections of the pump laser. The first crystal is tipped forward and the second crystal is tipped backwards. So when you replace the crystal, you'll want to put the new crystal on the block in the same on the same side. Fortunately for the OPA stage, all of the crystals are very close to normal incidence at 745 nanometers, so I can get there simply by scanning the system to 745. Okay, and that's very close. You can see the position for the second OPA crystal is very close to 0. Since we're going to be removing it, I'm just going to leave it in that position. Now, to access the set screw, I'm going to need to rotate the crystal. I'd like to bring it counterclockwise to bring the set screw towards me. And so to do that, I'm going to need to change the setup parameters for the motor. I'd like to increase the lower limit so I can move it farther than it normally goes. I'll add a couple of zeros. And multiply the base speed by 100 too, making it 20 instead. Okay, now I can scan until I can easily access the set screw. It's an M2 set screw, so you can simply use a M1.5 driver. Before removing the crystal from the block, note the orientation of the plus sign on the crystal. It'll either be on the top side or the bottom side. When you're replacing the crystal, put the new crystal on so that the plus is in the same orientation. I use Scotch double-sided tape in order to bind the crystal to the blocks. To release that, you'll need to use a fair amount of force, but constant pressure will allow the seal to break. Grab the crystal in one hand, the block in the other, and apply pressure until the seal releases. You'll want to put the new crystal on the same side of the block as the old crystal was, so we'll need to take off the old tape and use a piece of regular Scotch tape to clean up any little pieces that are left. Okay. I'll put a new piece of Scotch tape on, or the double-sided tape. And then trim it with scissors. so there's no overhang. Okay. Now, the block down, I'll take the new crystal and put it next to the block, rotate them both, and then slide them together on the table. You'll want to have a little bit of overhang on the front side. There. So the new crystal is ready to go. Okay, I've got the new crystal into position. All I need to do is rotate it back to normal incidence. It'll be clockwise direction. That looks very close. Oh. Yeah. You can see it's the very bottom spot there. Move it to normal incidence. Go into the setup window and set its position to read 0. And don't forget to set the base speed back and the lower position limit. Now you should be able to find lasing for the system for that crystal within plus or minus 1,000 counts or so.